Hi everyone, welcome to the 5th installment of SMT's webinar series. And thank you for taking the time to join me today. My name is Rupesh Patel and I've been working at SMT as a software engineer for around about 2.5 years. During this time, I've been actively involved in the development of various functionality, which I'm going to show you today. Today's topic is Parametric Studies and Design of Experiments in MASTA and RUNNA, and will entirely involve software demo. By parametric studies, I simply mean analyzing the impact of changing various input parameters on selected entities within the design. So, there are several ways in MASTA where we can perform parametric studies. We've got macro geometry design space search, which was covered in webinar 3. It allows for macro geometry optimization of a single gear set and provides an interface for users to explore many possible candidate designs as opposed to just giving a single answer. Microgeometry design space search is a newly added feature in MASTA 8.2, which has a very similar interface to macrogeometry design space search. It again works on a single gear set but allows for microgeometry properties to be changed and outputs such as transmission error and contact patches to be analyzed. We also have the Parametric Study tool, which is one of the features I'll be demonstrating today. It allows for linear sweep, Monte Carlo, and full factorial design of experiment analyses to be conducted on your designs. As opposed to the design space search features, which work on single gear sets, Parametric Study tool works on a system level. Examples of use include manufacturing tolerance studies or bearing preload studies to find optimum preload. In this webinar, I'll also be demonstrating our RUNNA software. RUNNA allows for scripting of MASTA analyses, so the power of MASTA can be utilized without the GUI. It can also be used for design optimization by easily linking it with third-party programs such as EyeSight, ModeFrontier, and MATLAB. One example of this is housing rib shape optimization using ModeFrontier along with RUNNA and a morphing software. Such optimization is beyond the scope of this webinar, but you can contact our support team to arrange a WebEx if you'd like to know further information on how to set up for such studies. So I'll just pull up MASTA now. So the concepts I'm going to show you today will be performed on rather simple MASTA models taken from our examples menu. This is purely to save time on computation of results, so we're not waiting around too long for analyses to finish. However, everything you see will be transferable to your more complex models. So to start off, I'm just going to use the scooter gearbox. I'll open the model. Just go to Parametric Study Toolboard. I'll just abbreviate that as PST from now on. On the left-hand side, we've got a tree view where we can select design entities on which we want parameters to be changed later. This can also be selected using the 2D and 3D view tabs. In the bottom here, we've got a load case control, and parametric studies can be performed on either single load cases or compound load cases. So this can just be changed here. I think today I'll just focus on single load cases. We have an editor tab, which is where you define options for the PST. So you can choose your study type, linear sweep, Monte Carlo, design of experiments, and an analysis type, so system deflection, or for example, if you're interested in running gear 1 analysis, you can just change it here. You can choose to log reports as well, which I'll go into a bit more detail later. Other tabs up here, so you've got the setup tab and the data login setup, which is where you define inputs and outputs for your study. And then you've got several tabs here to view the results. So for this first example, I'm going to perform a linear sweep on profile barreling relief and look into how transmission error, which is a key contributor to gearbox noise, is affected. So linear sweeps can be performed in either 1 or 2 dimensions, and added parameters will be varied linearly with equal steps within their specified range. Since barreling is a design parameter and not a load case parameter such as torque or temperature, I'm going to have to click change in design here. It's probably useful also to know which flank is loaded so I can change the macrogeometry on the correct flank. So if I go to macrogeometry mode, just run an analysis here. So I'm going to be changing microgeometry on the output gear. So I'll just look at the LTCA results for the output gear. So you can see the active flank here is the left flank. So if we go back to Psd, just go to the Setup tab to add some inputs, and then click the pinion on the output gear pair. And then I'm going to find barreling. So it's sometimes useful to use this search box to narrow down the properties. So it was the left flank which was loaded, profile, and I had barreling. Sorry, let's do that again. I'm going to vary that from 0 to 20 microns. And for the outputs, I'm going to log the transmission error and the maximum contact stress. So peak to peak T and the maximum contact stress. I'm just going to run the analysis. It shouldn't take very long to finish. So results are available in graphical form in this linear sweeps charts tab. So if I select an entity on here which has some results, so we log things for the pinion to wheel on the output gear pair, so this button is active, and it adds the TE and also the contact stress. So we can see for this simple example here, we've got an optimum barreling of around about 11 microns to minimize the transmission error. It's probably worth pointing out that any graph in MASTA, you can get the data out by right-clicking copy to clipboard and exporting it. And just paste it into there, so you've got the numbers, so you can save results basically from Psd using that technique. Or if you go to the Reports tab, you can see a table of the results as well, which can also be copied to the clipboard. So it tells you what was the inputs and the outputs. And from this table, you can also choose to save a particular design that you're interested in, or you can open the design in a new MASTA tab. So for example, this one here, which has low TE, you can just open that design, and it will open there in another MASTA tab for me. Just go to the microgeometry, show you that it's changed. So you can see this design has a barreling of about 11, which was the design that we added from the Psd mode. Just close this. So a recently added feature allows you to copy and paste Psd setups between load cases. This lets you run the same study on different load cases without the hassle of having to set it up again. So we've got this full load case setup. I can just copy that setup to the clipboard, which includes the inputs and the outputs and the information here. I can just paste it into the 5% load case, and then I can easily just run that to get some results out. And then you can easily compare results from different load cases by just toggling between them. So you can see here, this is slightly different optimum barreling relief, about 2 microns. So I'm going to add another dimension to this study. So if I go back to the Editor tab, I'm going to change the number of dimensions to 2. Just to save a bit of time, I'll just put 5 steps in each dimension. And then on the second dimension, I'm just going to add torque as an input. So let's select the input power load. Sorry, I meant to conduct that on the full load case. I'll just do that again. and just change that to dimension 2, I can leave the outputs to be the same. So again, you'll be able to see the results in the Reports tab. You can see the step numbers and inputs and outputs. And this time the Linear Sweeps tab shows a surface plot. And you can see here the optimum barreling is changing as the input torque changes. We've got a little valley here, the results. So that's it for the linear sweep. And the next example will be on a Monte Carlo analysis on planet pin position errors, and we're looking to how load sharing is affected. So if I just open the simple planetary example, just going to go to PST mode and change the analysis type to Monte Carlo. And in the Setup tab, it's going to find the planet pin errors. So a tangential error. In the Monte Carlo analysis, parameters can be varied with the normal distribution by specifying a mean and standard deviation, or they can be specified by a uniform distribution by using a minimum value and a maximum value. But I'm going to leave this as normal distribution with this study. One tip is so now instead of adding each property for each pin separately, we have the option here to add all entities of the same type. So if I select this option and click on tangential error for this pin, you'll see that it adds it in for all the pins, so it saves you time. So for example, if you're looking at preload on all bearings, for example, you can just select the preload from one bearing, and having that as all entities of the same type will add in that property for all the bearings in your design. And another thing is, you can also group select and delete these by selecting a few of them and either pressing spacebar or enter. So that will just get rid of them there. I'll just put those back in. So that's just a demonstration. So in this example, I'll do a standard deviation of 3 microns. And I'll log the the calculated worst load case sharing factor. Just going to run the analysis. So the results are available from Monte Carlo analyses in the Reports tab. So if we go to the Reports tab and select an entity here which had log results, I'd see the distribution of the results in a histogram form. So in this example, the worst load case, the worst load sharing factor has changed from about 1 to 1.08, which is probably acceptable for this simple example here. In MASTA 8.2, the ability to log reports on selected design entities from PST mode was added, and it's worth giving you a quick demo on how you can use it. So if I were to go to, so in this case we're running system deflection analyses. So if we were to go to system deflection and create a custom report now on, say, this planetary gear set, so select the gear set and create a custom report. And I'm going to add in the contact patch. There's a few properties here worth mentioning. So we've got the basic LTCA results, and we've got this thing called basic LTCA results, only first planetary mesh. So I'm going to use this one to save a bit of time. So rather than running all 6 planetary meshes, it will only run and give me results for 2 of them. So we've got the 2 results in there. So the new report here is the active report. So if we go to PST mode and select log report, we just need to choose a folder to save these reports in so they can be accessed later if we need them. Just going to reduce the step number because it takes a bit of time to save reports sometimes. I'm going to leave that the same, but in the login on the planetary gear set, I'm going to select the active report. So that's going to be saving the active report onto the disk and also for us to view in the single step results tab. So if I run this analysis, go to reports just to see which. So if I go to the single set results tab and click on something which has some logged results, so for example the planetary gear set, we can see here the report that the active report was logged, and I can see the results for various steps of my analysis. And they'll also be saved to the disk so you can view those reports anytime you'd like. So you obviously can make much more complex reports containing tables and lots of properties. This was just a simple demo of how you can use this feature. So for the final example, I'll be performing a design of experiments analysis and looking into bearing damage. So for this, I'll use the car axle example. Go to Parametric Study tool. Change this to design of experiments. So for a design of experiments, the number of steps is a read-only property, so you can't change it like you could with the linear sweep and the Monte Carlo. This is because this number comes from the number of inputs that you have and the number of steps those inputs have. So if I go to the setup to add some things in, just remove that thing which is default. Sorry, I was just going to change in design. I'm going to add in the oil sump and inlet temperature first. And in design of experiments, you can either have these variables varying linearly or non-linearly. So I can just input some values here that I would like. Or I could use a range and the number of values being 3 here to do it linearly. So that's the temperature in. The next thing I'll add is the oil filtration and contamination, which is a lubricant property. In MASTA 8.2, the lubricants are now in the database, and for that to appear here in PST, the database item needs to be a custom database item. If I were to go to the design mode here, we'd see our lubricant is in fact a custom item. So if I was to select the default lubricant, which is there, and then go to PST mode, we wouldn't see the lubricant properties there appearing. So one of the benefits of design of experiments is you can add bools and list items. So for example, the oil filtration, that's a list. So I can just select particular ones that I'm interested in. Let's just choose 3 from here. So the next property I'm going to add is point load radial magnitude. So if I go to the 2D view, we'll see here this bearing has a radial force on it. I'm just going to vary the magnitude of that force. Oh, sorry. I'm just going to go from 5 to 15. 3 steps again. I'm going to also add the speed for this power load. You need to be careful to put this back to single entity, otherwise it'll, like you just saw there, it adds it for both power loads. I'm going to go from 500 to 2000. I'm going to also choose the roller profile type on the tail bearing. Let's add in a couple of these things. And the duration of the load case. So with this combination of inputs, if you go to the Edit tab, we can see there's 486 steps to be run. Another thing you can do in design of experiments is you can group things together. So for example, this speed and duration of the load case could benefit from being linked together. So 500 will go with the 210, the 2000 revolutions per minute would go with the 88-hour duration. So I can create a group here, and anything with the same number of items or steps can be grouped with this one. So I'm going to just group these two together. So now if you go to the Editor tab, we'll see that the number of steps is reduced by a factor of 3 to 162. For the outputs, I'm just going to monitor the modified life damage on all the bearings. I'm going to play that. I think it'll take about a minute to run. Okay, so results from this study can also be viewed in the Reports tab, containing a huge table with all the inputs and all the outputs. And they can also be viewed in the Charts for DOE Results tab. So here we have two charts that we can view the results as. So we've got the main effects chart and the interactions chart. So I'll just show you an example of the main effects chart. If I select an entity with some results, for example, the tail bearing, and select an input, so say temperature, we can see here the change in temperature along this axis not really having much effect on the damage life. Whereas if I were to select something like the oil filtration or contamination, we would see here there is a significant effect when there's no filtration. Or similarly for the radial load, increase in the radial load, you can see a huge difference in the damage life, the life damage. So the interactions chart shows you the interaction between two parameters. So let's select temperature and say the radial force. There's no interaction between these two. So the lines are not crossing. As opposed to this, you can see some interaction here between the temperature and the group A, which was the speed and the duration of the load case. Okay, so I think that's it for Parametric Study Tool. And the next part of the webinar, I'm going to focus on RUNNA. As I mentioned, RUNNA allows for scripting of MASTA analyses, so that analyses can be run without the MASTA GUI. It can be launched from the Start menu or from within MASTA by having a design of interest open. So I'm going to open it from MASTA. So I'm going to open an example. I'm going to go for the simple housing example. And then if you go to File, Open in RUNNA, it's going to ask if the design can be saved. I'll just save it to a location on my disk. So this is the RUNNA editor window, and you can see it's got a very similar feel to the Psd mode. So here you can select your design, which has just come in now from MASTA. You select an analysis case. Again, you can either run this on load cases or duty cycles. I'm going to select this load case. And then you need to specify a working folder where files which are generated by RUNNA can be saved into. So let's create a new folder in here. So in this example, I'm going to look at the effects of crowning, barreling, and torque on the transmission error, the contact chart, and also the housing response. So if I change the analysis type here to gear wine analysis, so I can get the housing response results, I'm going to go back to my model and see which flank is loaded again. So microgeometry mode. Let's run the load case. So in this example, it's the right flank. Select the pinion. I'm going to add crowning and barreling, and then the torque on the input power load. These min and max values, they can be ignored. So if you were linking RUNNA with eyesight, then these values would be used with the eyesight program. But since for this demo I'm just going to be using Excel, these can be left as 0. And for the outputs, I'm going to add the transmission error. And in RUNNA you can also output images, so I'm going to output the actual contact chart. And if I select the housing, I've got an option here to export accelerations. So when you're exporting accelerations or forces, you need to make sure your MASTA model is set up correctly to do that. So if I go back to MASTA, let's go to NVH mode and run a gear line analysis on my load case. And then if we go to the export tab, I can see here this is set up at the moment to export the files as an FE package extension. I'm going to change this to raw text. So this will export the results from RUNNA as a text file, so they can be read by programs like MATLAB or something to get the frequency response functions out. I'm going to save this design. So back to RUNNA. It's probably worth mentioning here that some of the properties have particularly been added into RUNNA as a request of customers. So please don't hesitate to contact us if you think there are properties which would be useful for your cases but are missing here. And save the file. And it's going to ask me here to create, if it can create an Excel file for batch running. I'm going to click yes here because this Excel file contains some VBA code that we wrote to help demonstrate the concept of RUNNA and using RUNNA from a third-party program. So I can close RUNNA now. I'm just going to go to the folder where the RUNNA file was saved into. And if I open this with a text editor, I can just show you how simple this file is. So it contains settings at the top here, things like the load case that we selected, the working folder, the analysis type that we're running. The next section here is the inputs. So we added the 3 inputs, the crowning, the barreling, and the torque, and these values that you currently see, they're from the current design. The next section of the XML file is the output definitions. So you don't really need to worry about this. This is kind of used by us internally. The next section that's interesting for you guys is the output section, where results after a RUNNA analysis has been run will be populated. So these value fields will be populated with the results. So I'm going to just use the command prompt to simply demonstrate how this file can be run and populated. So if I just change these numbers a little bit. So that's like one set of inputs there. And then I can, in command prompt, I'll put the path to the RUNNA file. Sorry, it's firstly I need to put the path to the RUNNA application. and then the command run fast, and then the path to the runner file, and then enter. So this is the runner, and this is where the jobs will be sent to, and this also holds on to design, so if I were to send another job to this, then it wouldn't have to waste time loading the design again. So that's finished now. So if I go back to my runner file, I can see here the peak-to-peak transmission error, the path actually to the contact chart, and the path to the housing response has been included into these outputs. So we've got to runner files. You can see here the images, so that's the contact chart, and in here will be the response of the housing. So now I'm going to use the Excel file which was generated to demonstrate that you can send jobs in batches. So this is the file that was generated by Runner. It contains two tabs, the Control tab and the Work tab. So at the moment the Work tab is empty. Press Populate Work tab, it will read that Runner file and then populate this accordingly. So these numbers are usually from the original design, but because we changed them, they've come from the changed design. And here you can specify the values for the inputs, and then once you run the analysis, the values here will be populated. So I'll just put some numbers in here. And then here I need to define which is the first row with data and which is the last row. So the last row in our case is 24 and the first row is 16. So 16 to 24. And now I'm going to just create the runner files. So by pressing that button, if we go into our SMT folder, we can see temp files. So each of those rows has been converted to a runner file. So if we were to open one of these, you can just see the numbers of the inputs being populated. And I'm going to run the analysis. So that's finished now. I can just update the worksheet. And you can see it's populated here with the numbers for the TE, some links to the files for the contact chart, and some links to the files for the housing accelerations. I can use this little button here to nicely convert the images straight into the Excel file. You can see the contact chart changing. So I think that's it really. I think that ends the demonstration part of the webinar. So I'd be happy to answer any questions you may have regarding what I've showed you today. So it doesn't seem like there's any questions coming through at the moment. So that's it from me really. I hope this webinar has given you a sound overview of Parametric Study Tool and Runner so they can be utilized during your design processes. If you have any specific requirements, as I said at the beginning, just contact our support team and we'd be happy to assist you. Thank you for listening to me today. Just quickly mention our next June webinar topic will be released shortly and details can be found on our website. So look out for details and register your place. Thank you again for attending today.